What if humanity's next great colony wasn't Mars, but the moons of Jupiter, where the skies glow with radiation, oceans hide under ice, and alien life might already exist? Sounds like sci-fi? NASA thinks otherwise. This is what it would take for us to survive in the most dangerous and most promising region in the solar system. Awards. And it's within these moons that the next chapter of human exploration might be written. First we have Europa, smaller than our own moon, yet with an ocean of liquid water potentially larger than all of Earth's oceans combined. Imagine that, a hidden sea cradled beneath miles of ice, warmed by tidal forces and perhaps, just perhaps, teeming with life. But Europa's beauty is a siren song. The radiation environment is fierce, deadly. Living on the surface would be impossible. We'd need to burrow deep into the ice, seeking refuge in the moon's watery depths. Next, there's Ganymede, the largest moon in our solar system, even bigger than the planet Mercury. Ganymede has its own magnetic field, a rarity for a moon, which offers a level of protection from Jupiter's radiation. While its surface is a mix of ancient craters and younger icy plains, there's evidence of a vast, salty ocean beneath its crust. Ganymede might not have Europa's potential for life, but it offers more real estate and a slightly less hostile environment. And finally, we have Callisto, the outermost of the three. Callisto is a survivor, its surface pockmarked with craters, a testament to eons of asteroid impacts. But it's also the furthest from Jupiter, meaning the radiation is less intense. Callisto might not have the active geology or subsurface oceans of its siblings, but it offers something invaluable: stability and relative safety. So, where do we set our sights? If safety is paramount, Callisto is the clear winner. If resources are the priority, Ganymede, with its potential for water ice and even underground aquifers, takes the lead. And Europa? Europa remains the wild card, a tantalizing possibility for scientific discovery, but with risks far greater than the others. mental well-being in the face of constant challenges. Chapter 4. The Mind in the Machine. Imagine a sky not of blue, but of swirling ochre and crimson, a constant reminder of the giant that holds you in its gravitational embrace. Imagine a world where the sun is a distant pinpoint providing little warmth, casting long, eerie shadows across the icy plains. This is the reality we would face on a Jovian moon, a reality that could test the very limits of human resilience. The human mind craves the familiar, the rhythms of day and night, the changing seasons, the feel of wind on skin, the sound of rain. These are the things that ground us, that connect us to our planet, to our humanity. But on a Jovian moon, these primal comforts would be absent. We would be surrounded by technology, our lives dependent on its flawless operation. Every breath of air, every drop of water, every calorie of food would be a testament to human ingenuity, a victory against a relentlessly hostile environment. But at what cost? Isolation, confinement, the lack of natural light, these are all known to have profound psychological effects. We'd need to create artificial environments that mimic the Earth's diurnal rhythms, complete with simulated sunlight, perhaps even projected landscapes of forests and oceans to soothe our weary souls. Virtual reality could provide an escape, a temporary reprieve from the confines of our artificial world. Imagine strapping on a headset and finding yourself walking through a forest, feeling the sun on your face, hearing the birds sing, all while millions of miles away, your physical body remains safely ensconced in its subterranean habitat. Mental health would be paramount. We'd need to send not just engineers and scientists, but also psychologists, therapists, artists, individuals who can foster a sense of community, who can help colonists cope with the psychological challenges of living in such an extreme environment. Chapter 5. A Cosmic Gamble, Why Jupiter? So, you might ask, why risk it? Why subject humanity to such hardship, such isolation, such psychological strain? Why not focus our efforts on Mars, a planet that, while challenging, seems downright hospitable compared to the Jovian system? The answer, my friends, lies in the potential rewards. Jupiter's moons aren't just stepping stones to the outer solar system, they are destinations in their own right, offering a wealth of resources and scientific opportunities we can't afford to ignore. Let's talk resources. Water is essential for life as we know it, and Jupiter's moons have it in abundance. Locked away as ice, but accessible nonetheless. Water can be used for drinking, for agriculture, even for generating rocket fuel. And where there's water, there might be other volatiles like ammonia and methane, which could be used as fertilizers or even as fuel sources. Jupiter's moons could also hold clues to the origins of our solar system. Their icy surfaces and subsurface oceans are like time capsules, preserving remnants of the early solar system in their pristine state. By studying these moons, we can learn more about the conditions that led to the formation of our planet, and perhaps even the emergence of life itself. And what about life beyond Earth? Europa's subsurface ocean is considered one of the most promising places in our solar system to search for extraterrestrial life. If life can exist in that cold, dark ocean, then it might be more common throughout the universe than we ever imagined. But perhaps the most compelling reason to venture to Jupiter's moons is to establish a backup for humanity. Earth is facing unprecedented challenges: climate change, resource depletion, the ever-present threat of asteroid impacts. Establishing a self-sustaining colony on a Jovian moon could provide a safe haven for our species, a lifeboat in case disaster strikes our home planet. Chapter 6. A Future Among the Stars. Imagine a future where humanity has established a permanent foothold in the Jovian system. A future where sleek spacecraft ply the space between the moons, transporting people and supplies, their fusion drives glowing a faint blue against the blackness of space. Our initial outposts would evolve into sprawling settlements, perhaps even cities encased beneath massive radiation-shielded domes. We might even see the rise of floating cities, suspended in the upper atmospheres of Jupiter's gas giants, harvesting energy from the planet's powerful magnetic field. Intermoon travel would become commonplace. Imagine hopping on a high-speed rail system that whisks you through a tunnel bored through the ice of Europa, connecting you to a bustling research station on the other side. Or boarding a spacecraft and arriving at a mining outpost on Callisto just hours later, the journey a blur of stars against the inky void. Over generations, the colonists might undergo adaptations to their new environment. Perhaps they'll evolve to be taller and thinner, their bodies better suited to the lower gravity. Or maybe their skin will develop a natural pigmentation to protect them from the intense radiation. And what about the culture of these Jovian colonists? Living in such an extreme environment would undoubtedly shape their values, their beliefs, their art, their very way of life. They would be a new breed of humans, spacefaring, resourceful, and perhaps a little bit more philosophical than their earthbound counterparts. And if by some stroke of cosmic luck we discover life in Europa's ocean, well, that would change everything. We wouldn't just be colonists anymore, we would be neighbors, sharing a solar system with another intelligent species. The implications for science, for philosophy, for our understanding of our place in the universe, they would be profound. Outro our Jovian destiny. Colonizing Jupiter's moons wouldn't just be a mission, it would be a test of human will, technology, and survival. But it may also be our first true step into the deep universe. Imagine, humanity, a species that evolved on a pale blue dot, now making its home among the stars, pushing the boundaries of knowledge, and perhaps even encountering life beyond our world. And if life already exists there, we're not just moving in, we're becoming part of something bigger. We might find that we are not alone in the universe, that life in some form is not the exception but the rule. Subscribe, because the next series will take us even farther. We'll venture beyond our solar system to distant stars and planets, exploring the endless possibilities of the cosmos. Join me, and let's continue our journey together.